Attention Earth! The mountain moving project is currently underway. Target lock, Hong Kong, China. Beneath this mountain, Asia's largest man-made cavern complex is about to emerge. With a volume of over 2 million cubic meters, it could hold 4 Fujian aircraft carriers, or over 5,600 high-speed rail carriages. What is this massive cavern for? And how did we achieve all this? Welcome to the Institute for Planet's new explorations of works of nature. This time, let's embark on a real-life mountain-moving project. This is a concrete jungle. To accommodate over 7.5 million people in limited space between the mountains and the sea, for over a century, people have reclaimed I and from the sea, creating a total of 78 square kilometers of land. This is equivalent to creating another Hong Kong island. But I and reclamation cannot solve all problems. When we look at the east, you will see unique structures. This is Hong Kong's largest secondary sewage treatment plant. In Hong Kong, where a square foot of land is worth a square inch of gold, roughly equivalent to 39 standard football fields. If only it could be relocated. But where could it be moved to without taking up land or affecting nearby residents? The answer lies in the giant cavern shown at the beginning of the video. In fact, this isn't the first time Hong Kong has moved structures underground, for this place is simply the chosen land for cavern excavation. 80% of Hong Kong's land surface is made of volcanic rocks formed when magma erupted and cooled, and granite deep within the Earth's crust. Most of them were formed by the cooling and crystallization of molten magma. Thus, they are hard and dense in structure. This solid and stable foundation, coupled with extensive steep mountainous terrain, renders over half of Hong Kong's land suitable for cavern development. For this reason, the HKSAR government delineated 48 strategic cavern areas, including Nui Po Shan, opposite Sha Tin sewage treatment works across the river. However, to accommodate a sewage works of such immense scale, we must launch a mountain-moving project and create a super cavern of 2 million cubic meters. This is a C919 aircraft, and this is the cavern we are excavating. It doesn't look that big, but in fact we're not excavating just one cavern, but a super cavern complex composed of 15 chambers, arranged in a 7 vertical, 4 horizontal pattern. Among them, the largest chamber has a sectional area exceeding 900 square meters. So, here comes the question. How was such a large chamber created? Excavators? Too slow. Tunnel boring machines? Too small. Then we can only use the most traditional method, blast. Thus, 2 smart tunnel drilling rig known as Jumbo were used by engineers from CSCEC. They possess 3 heads and 6 arms just like NESA. Sensors installed on their arms can collect data in real time to ensure the accuracy of the drilling operation. In just 3 hours, they can quickly and accurately drill over 200 holes. After drilling is complete, workers load explosives into the holes. Check, evacuate, detonate. This is known as a drill and blast method. However, a jumbo can only drill up to 13 meters high, which is not enough to cover a cross-section up to 32 meters high. Since one blast isn't enough, we'll just blast multiple times in sections. The entire cavern complex requires a total of 2,500 blasts. Yet, outside the cavern, the sound is barely audible. How is this achieved? The key lies in the method of detonation. The holes are equipped with high-precision delay devices. By controlling the delay time of each borehole, they are detonated sequentially. This way, vibration waves can be stacked and canceled out. Thus, the intense, concentrated blasts are transformed into continuous micro-explosions. Coupled with blast doors and other soundproofing facilities at the tunnel entrance, the impact of blasting on nearby residents is minimized. But at this point, engineers face a second challenge. How to ensure such a large hole doesn't collapse? Perhaps we can consolidate the rocks. First up is fiber-reinforced shotcrete. It's sprayed onto the rock surface after blasting, filling cracks. Next comes the soul of the system, the rock bolts. They connect the internal rock mass using friction between rocks to maintain stability. This is the bolt shotcrete method. Normally, the combined use of shotcrete and rock bolts is only a temporary method, but engineers found an ingenious solution. They encased the rock bolts in plastic pipes, and after tightening, injected cement grout both inside and outside the pipes. This creates 2 layers of anti-corrosion protection. Then, fiber-reinforced concrete is sprayed again for further reinforcement. Thus, temporary support is transformed into permanent support. Compared to traditional lining and requires reinforcing mesh and other structures, this greatly streamlines the process. But have you ever wondered, a 2 million cubic meter cavern means we need to remove 2 million cubic meters of rock. With so much rock, is there a better way to handle it than simply disposing of it? Of course. Engineers from CSCEC chose to crush it into aggregates, and then process it into concrete for recycling. Besides recycling the rock, they have also taken various measures, such as replacing diesel machinery with pure electric machinery, significantly reducing carbon dioxide emissions. By then, we had already relocated and excavated, creating Asia's largest cavern for civil purposes. But this isn't enough. We also need to create a complete underground factory. This is Hong Kong's first sewage treatment works located inside a cavern. Similar to surface sewage treatment works, it requires processes like screening, biological treatment, final sedimentation, and disinfection to transform wastewater into clear water. However, in the biological treatment stage, there is something different. A group of microorganisms is added here. They feed on organic pollutants. In traditional open-air sewage treatment works, these microorganisms float freely in the water. But in the cavern sewage treatment works, porous plastic carriers are introduced. These provide more footholds for the microorganisms. Using this method and other measures, the Sha Tin sewage treatment works requires only half the area of the original one, yet can efficiently treat sewage for 1/10 of Hong Kong's population. Beyond sewage treatment, solving the ventilation issue within the cavern is equally important. To minimize impact on nearby residents, ventilation shafts were built high up on Nui Po Shan, connected to the cavern system by a 660-meter-long ventilation adit. Further inside, an overhead ventilation duct constructed from about 4,500 prefabricated components is responsible for airflow within the cavern. This way, even hundreds of meters deep inside the mountain, one can breathe freely. Adding effluent pipes, ventilation buildings, and other ancillary facilities, along with a smart site safety system built with industrial sensors, smartwatches, 5G, and Wi-Fi networks, and a temporary flyover for construction vehicles. With the joint efforts of the Drainage Services Department and other partners, we will finally relocate Hong Kong's largest secondary sewage treatment works into caverns. Once the works is relocated, the space freed up on the original site can provide Hong Kong with 28 hectares of new land, which will light up countless new homes. And by then, when people living on this new land look out their windows, they might not connect the fresh breeze and clear water with the serene green mountain opposite. For its perfect presence lies in being unseen.